Hello, everyone. So we are going to talk about basic statistics, and this is a review session for us, just to make sure everyone is on the same page for this course. Chapter 1 is introduction, and we will talk about, in general, what statistics is, and some basic ideas. Statistics is a discipline. And we answer questions we can answer with the statistics. We will talk about variation. I can say variation and pattern and models are the most important topics in statistics. So what is variation? Of course, for example, if everyone in this world, they behaved exactly the same. So we didn't need to study people's behavior. We didn't need to understand how they decide to buy something or decide to go somewhere and make decision about their life, right? So the main reason that a statistic exists is that variation exists. Now, variation is when you have different variety of things, and when especially people behave differently, it's difficult to make a decision for all of them. So we as managers, we want to make decisions that work for most people, and that help us to control, right? Control a system and achieve our goals. So for example, if you are a manager of a bookstore, manager of a for example, Macy's, right? Your main goal is to have a higher sales and higher profit and higher revenue, of course. There are many factors, there are many things that, in fact, help us to have a higher sales. And those factors, if we look into them, we can see that who is buying so we can have sales? People, right? So we need to understand how people decide to buy things, why they decide to buy, what makes them happy, what makes them to buy again, and what makes them to recommend our store to others to come and buy from our store. So understanding this variation of people requires statistics, requires collecting data, collecting and getting information from people, and in fact, trying to understand and come up with a general rule for all of those customers, because you can't make decisions for each customer separately. It's very difficult. You have millions of customers in Macy's, right? Every day. So it's very difficult to make for each person one decision at one time. So we need to come up with some general rules that all of these people are having in common, right? And from those factors, come up with some ideas and decisions that maximizes our sales. So that's generally what we talk about variation. So as a manager, managers don't like variation. Why? Because it makes it more difficult to make a decision for everyone. So we prefer a controlled or minimized variation. If there is too much variation, your decision might not, in fact, work for that business. And pattern and models. So patterns are talking about similarities of behavior. So when we see that there is a similar behavior in a certain case, like maybe we can say when there is a discount, people might want to buy more, right? If we give discount, if we tell them, hey, there is 75% discount, so they're going to buy more. This is a pattern. And if we understand this pattern using data analysis, by analyzing our information, then we can make a decision up to what percent should we give discount so we can maximize our sales. So Hopefully that makes sense. What is a statistics? A statistic is a science and art of extracting answers from data. A statistic is a property of data. So statistics is a variety of properties of data. And statistics can be numbers or graphs that display the information. So how do we get those answers? What's the right price for the notebook tablet? Which customers are interested in tablet computer? How much are they willing to pay? Of course, not everyone is willing to pay exactly the same thing. That creates a variation. So we need to come up with like average, standard deviation. That's going to help us to understand what range of prices create sales, okay? We did talk about variation. So there's variation among customers, making these questions harder to answer. Variation refers to differences among items, individuals, or fluctuations over time. The statistics provides methods to handle variation. Patterns and modes. So patterns are systematic or predictable features in data. A statistical model breaks down variation into pattern and unexplained variation. The pattern represents variation we claim to understand. Statistical models. So statistical models are the key to extracting answers from data. So good models simplify reality. And again, a good model is actually created by a good data collector. Of course, most of the time we don't have access to all the data. For example, if I decide to get information from students at Sac State, not everyone is interested to answer questions. So as a result, we don't have the whole population. We have a portion of it, which we call it the sample. And whenever you select a sample, you are missing some information because you're missing some information that reduces the accuracy of data. That difference depends on how the sample is collected. That actually has effect on your model. And your model, what is the model? Model is how mathematically we can formulate the pattern, the behavior of our respondents, okay? So good models simplify reality, minimizes the complexity. Finding real patterns help us to understand data, plan for future, and make better decisions. Predicting employment, for example, that could be an example of, so we can look at the previous years of employment and how it's behaving. So we can see that it's going up. So 2, 3, 4 years is going up. We can predict that the next month or the next 2 months, the next 3 months, next quarter, next year, we're going to have almost the same increase. So if I show you here, you can see that if I cut this from here, let's just consider from 2004 to 2006, right? This is almost similar to a line. We call this a linear relation because a line can actually show this pattern. And using that line, we can predict the next employment or unemployment values, right? And come up with some solutions. That's what I just said. So you can see that. And of course, it's not 100% true because first of all, we don't have access to the whole population, first of all. Second, when we do calculations, for example, when we calculate average, right? There is always some kind of rounding involved, and rounding means error. And that error creates error in decision making. So when we make a decision that next year employment is going to be For example, 5% up or 5% low, right? That 5% is coming from an average, which has error. So that 5 is not accurate. There is an upper bound and lower bound around it, maybe by 1%. So we can say with 95% accuracy, it's between 4 to 6%. All right. In conclusion for this chapter, actual employment for October is less than expected and below the anticipated range. This surprising result breaks from the pattern and deserves attention. So what else do we have? Another example, pricing a car. So these are available in the book. You can read this. Chapter one does not have any homeworks. All right. This review parts I did not give you any homeworks for. Okay, so let me close. Do you have any questions up to this point? Good. If you have questions, feel free to ask in chat or unmute yourself and ask your questions. So let's go to chapter 2. So chapter 1 was just an introduction, what we're going to do in general, right? What is a statistics? Chapter 2 talks about data. Data tables, some basic ideas. So data are collection of numbers, labels or symbols with context. A data is a rectangular arrangement of data with rows and columns. Observations or cases form the rows. So in the book, when you read the book, sometimes it says cases, that means the rows. Sometimes it says observations, that also means the rows. Common attributes or variables form columns. So instead of saying columns, sometimes the book says variables or it says common attributes. So remember these words, okay? I won't ask this type of question, never. I just want to make sure when you read the book, you're familiar with these names.
Professor?
Yes.
I'm sorry to interrupt. Just can you go over what cases mean again in this context? Where it said on the previous slide?
Rows. So look here, it says data are a collection of numbers, right? And here it says a data table is a rectangular arrangement of data into rows and columns, like an Excel file, right?
Yeah.
You have an Excel sheet. That Excel sheet has rows and columns.
Yeah, yeah.
Okay, that's what we're talking about. So rows, we also name them cases or observations. And,
okay, I see.
Okay.
Thank you.
You're welcome. So not every data given to you is organized. There are a lot of times that data given to you are disorganized. So one of the things we do when we learn in statistics is how to organize data. So if data are disorganized, we categorize them into different groups and put them in separate groups, and each group creates a variable. Like this case, you can compare these two slides. You all have the slides, right? All right, so, so we organize the data. Make sense? Data tables, organize data to yield meaningful information, provide context, like who, what, when, improve interpretability with meaningful names, formatting, and units. And data tables, so rows describe a collection of things, items, or people. So if you have seen the list of students, for example, on one side you have the name of the students, right? Each student name is a row. And next to it, each column give information about that student. Their age, their student ID, maybe their classes they took, and what major they are, right? So rows is also known as items or people, called observations or cases. rows, observations, cases. When you read the book, these are used as rows. Columns, we also call them variables. Variables or attributes, common attributes, or variables, or items. Okay, the number of rows of in a data table is denoted by symbol n. So that's in fact our sample size or population size. The number of rows, that's your sample size. Next is categorical and numerical data. There are different types of data, right? Categorical data, also called qualitative or nominal variables, they're identified by group memberships. For example, type of purchase made and brand of a bike, right? Or colors. Colors are qualitative. Can you give me another example of a qualitative or categorical variable or data? Just feel free, unmute yourself and say something.
Color?
Color, I just said color. Do you have
Oh, sorry, I didn't hear.
Other than color, what else can we say as a categorical? A good sign for categorical data is they are normally names, they are not numerical. You cannot represent them with numbers.
What about age, Professor? Would that qualify as
Age is number, right? We say, I'm 24 years old, I'm 50 years old, I'm 40 years old. So no, categorical.
States.
States, state of origin, for example. Country of origin.
About months.
How about what?
Months.
Can you type? I can't hear you.
Months.
Just
typing it.
say. Like gender, right? Male, female. Okay. Start thinking about different categorical variables and remember that. So another type of data or variables are numerical data or quantitative or continuous variables. They are represented by numbers, numerical properties. Have measurement units, size of a bike, amount spent, right? Can you give me more examples of continuous or quantitative variables?
Height.
Height, yes.
Distance.
Distance, yes.
Weight.
Weight, yes. How about in business? When you do business?
Budget.
Pardon me?
Budget and cash flow.
Budget,
Sales.
cost, revenue,
expenses.
Good. So those are numerical, okay? Okay, so let's move on. Okay, so levels of measurement or measurement scales. So this is very close and very, actually, I can say it's very similar to type of variable. So let me see if I can open a Word file here and actually explain that on a separate page. That way we can organize error, and you can take notes together with me. And let's change the layout to have more space. Make this bigger. Okay, so what we learned until now is type of variables. We have two types of variables, right? We have quantitative, quantity, right? Quantity is about numbers, so it's numeric. And we have qualitative. You cannot represent qualitative with numbers, so we call it non-numeric. Okay? So this is called a type of variable. What type of variable do you have? This goes back to the nature of the variable, that do we need numbers to explain that variable, or do we need words to explain that variable? The next is level of measurement. And level of measurement is a little different. Let me give you an example. So let's say we talk about age, and this is not a level of measurement yet, okay? This is just an example. In this example, we have age. And by nature, in fact, age is it numeric or is it categorical?
Numeric.
Numeric, because it comes from time, and time comes from numbers. So age is numerical. That's its type of variable. And that's in fact what we call it is quantitative, right? But the same thing that is age, let's say we are talking about a survey that we don't really need to know exact date of birth, or we don't know exactly if our clients or customers are having a certain age, right? Are in a certain age. So what do we need? Let's say our research requires only to know if these customers, clients are they old, are they young, or are they, for example, in middle age, right? So age also can be categorized, right? We can categorize age. How do we do that? In different ways. One way is you ask people their exact age and then create a range of ages, right? So create range of age. And by creating range of age, so what happens is, so you say, let's say from 20 to 30, maybe to 40, right? And then you say, I'm sorry, this is not what I want to do. And let's say we have this, insert a table, simple one. And we just say that this is age group instead of actual value of age. And we say, for example, 20 to 40, and then we say 40 to 60, 60, and 60 to 80 plus, right? Or maybe 80 to 100. So then these are not numerical anymore. These are numbers. These are categories. So category one. Then we have category 2. Does that make sense? Category 3. So we categorized something that is actually numerical. And this is called level of measurement. How we measure something. Maybe that something is not really numerical, or it's actually numerical, but we measure it in a categorical way. So level of measurement, in fact, doesn't have to be about the nature of that thing. It actually depends on how we need it. How we need it. Okay, so where were we? Level of measurement. So I delete this part and I explain level of measurement. So it's about what we need for research or for decision making, right? I could also create a, I can say, create a questionnaire. And in that questionnaire, I don't ask exact age to make groups. I just ask, for example, if it's in psychology, we could ask people, do you feel you're young? Do you feel you're middle-aged? Do you feel you're old? Or just two categories. Do you feel you're young or old, right? That's actually, I mean, it's still about age, right? But in fact, we are categorizing. So that's level of measurement. So level of measurement, we have 4 types of level of measurement. But to simplify it, I categorize it into 2 first. And those 2 first are categorical, type 1, right? And then it can also be continuous. Categorical or continuous. If it's categorical, there are 2 types of categorical variables. So let's see what types we have. Some categories can be ranked. You can put them in order from low to high, high to low, right? So if you can rank them, like what? Level of education. High school, bachelor, master's, PhD, postdoc, right? So we can rank them. We can say which one is lower from low to high, and that creates understanding of knowledge. So if you can rank it, that's called ordinal. And sometimes you cannot rank it, right? Sometimes you cannot rank it. So no rank. If you cannot rank it, we call it nominal. If you cannot rank it, we call it nominal. So again, there are 2 types of categorical levels of measurement or measurement scale, ordinal and nominal. Ordinal is when you can rank the categories. Nominal is when you cannot rank the categories. Can you give me example of, other than education level, let me write it, education level. That's an example. Can you give me one more example of, or you can type it in the chat, a categorical variable that can be ranked? Military pay scale, maybe military. Let's say military ranks, right? Do you accept that? CEO, COO, perfect. Levels, different levels of managers, right? Does that make sense, everyone? Okay, so next is, how about no rank? Can you give me an example of there's no rank? There are categories, but we cannot say which one is higher or lower than the other. Degrees. What kind of degree? The word degree is rankable. That's education level, right? We just talked about it. You can rank it. So we're looking for cultures. Cultures, yeah, we can rank cultures. Cultures. What else? Race. Gender, right? Color, and so on. So it's easy, right? It's not really difficult. So on your exam 1, I will ask about this, okay? I will give you a few questions and ask you, is this ordinal, nominal, continuous, categorical, and so on. So this is if you have a categorical value. And this should be like smaller, maybe. The next one is continuous. So we also have two types of continuous variables. We have, in fact, ratio. And we also have interval, or interval and ratio. What's the difference between interval and ratio? So the difference is ratio. Actually, this is a sign that can help us to understand ratio. And that's 0 exists. 0 has a meaning, like 0 cost. Anything that you can write it in a form of percentage, or you can write it in a form of a decimal, right? Those are ratio. So, can you give me an example for ratio?
Weight.
Say it again.
Weight.
Weight, yes, weight. What else can you say?
Points.
Weight, height, what else?
Price.
Mm-hmm. Do you have height of 0?
How about percentages, like percent yield?
Percent yield, yes. So let's focus on the height. If you're talking about a height of a person, do we have a person with the height 0? We don't, right? We don't have height of 0 for a person, but we might have height 0 when it comes to understanding Earth, right? There's a 0 height, above the height, below the height. So that 0 exists. So it really depends when we say height, what we mean by height. Height of a human, weight of a human, or we're talking about something else, okay? So this was correct. So this is height in general, it's not height of a human. Interval is just a little different, and that's, in fact, no zeros. You don't accept 0. 0 is not acceptable. When 0 is not acceptable, when 0 is not acceptable, that's interval. Can you give me an example of no zeros?
Time.
Time. What else? You said time, right? Can we have a time 0? Can you give me an example of a scenario that time becomes 0?
A stopwatch.
Yes. So you can have 0 for time as well. So it really depends on the case, right? What else do we have? How about age? Does anyone has age of 0? A person with the age 0 doesn't exist, right? If it's purely 0, it doesn't exist, okay? So time, it really depends, okay? It really depends how we look at it, depends. But age, definitely, you don't have age of 0. So do you see the difference between levels of measurement and type of variables? So these are, this is type of variables, right? And this one is level of measurement. Do you see the difference between these two? Maybe I can make this like green so you can see it. Do you see the difference between these two? The first one is the actual what the variable is. The second one is how we need it, okay? How we need it. So level of measurement is actually can be, the same variable can have different levels of measurement. But type of variable is always the same. When it comes to age, type of variable is always numerical because basically age comes from numbers. Are we good? Okay, so let me continue from the slides. So you see that here, nominal, name categories without implying order. Ordinal, name categories that can be ordered, low to high, high to low. Interval, no zero, no absolute zero interval. Ratio has absolute zero, okay? Also, we can say makes ratio comparison possible. Okay, next slide. Likert scale. So you have seen Likert scale when you answered questionnaires from different companies that you deal with. For example, you go to service your car. After a few days, they send you a questionnaire and ask you how the service was, right? And they normally put in different ranges. We have 5 scale or 7 scale. I have seen 10, from 0 to 10 or 1 to 10. So of course, you can break between the lowest and highest into as many values you like, but scientifically, it's just 5 or 7 Likert scale. Okay, so these are the scales. So starting from strongly disagree, strongly agree, strongly dissatisfied, strongly satisfied, and in the middle is always neutral or none, so or 0. Recording and aggregation. Do you have any questions up to this point? Any questions? We're all good, right? It wasn't that difficult. Okay, so recode is building a new variable from another variable, recording price into expensive or inexpensive, recording age into old and young, or into different range of ages, right? Aggregate is reducing the number of rows in a data table by counting or summing the values or averaging. So remember this too, okay? Recode, aggregate. I will not ask from those, but when you read the book, these are being used, so you need to know them. So that's an example of aggregation. Next, we have these are examples. You can read this from the book. So time series, there is one chapter that fully will cover the topic of time series at the end of the semester. I will cover that part. So I won't go over this at this point. But in general, time series is changes of changes in a variable, changes in data over time. Whatever changes over time, that means time is actually affecting, for example, oil price, for example, sales, right? So whatever is changing based on time, we call it a time series. And if we have a time series, if that time series shows some kind of pattern, and we can formulate that pattern, we can actually predict the future using that formula, okay? So that's what you're gonna learn in the future. And I think that's pretty much for chapter 2.